Yeah, we are live now. I hope so. Let me check. Alberto, can you check if we are live?
Yes.
And yes, we are live. Close the volume, or otherwise we will have a return. Okay. However, so dear friends, we are live with this webinar of the Space Renaissance Academy. Today we have with us Professor Quentin Parker from Hong Kong. He's an expert, among other things, of orbital debris, and he will give us a lecture on this topic today. Very important issue, the space debris. And yeah, we are also waiting. Ganim Alotaibi is having technical problems, but I will try to give a quick introduction of Professor Parker. Just let me recover the proper things. Okay, so the question of human health in space is not limited to the human condition inside the space station, but is increasingly dependent on the safety and health of the external environment. This is in terms of the orbital security of satellites, space telescopes, and space stations from the direct threat posed by the so-called Kessler Syndrome. It sounds like a medical condition or viral infection, and indeed, in some ways, it is. The Kessler syndrome would be the ultimate result of the unchecked infection of LEO by LEO, it means low Earth orbit, by vast swarms of large and small pieces of viral space debris, which, if unremediated, will lead to the catastrophic cascading collapse of the entire ecosystem, i.e. the destruction of LEO as a viable environment for any satellite or spacecraft. In this talk, Professor Quentin Parker will cover the issues and explore potential solutions, the most important of which is accepting responsibility and committing to international cooperation and, if necessary, unilateral action. So a short bio of Professor Parker. He's a PhD and BSc Hans, FRAS and FASA. Quentin Parker obtained a PhD from the University of St. Andrews in 1986 and joined the faculty of the University of Hong Kong in March 2015 to take up the headship of the Department of Physics. In 2017, he became Associate Dean Global of the Faculty of Science and Director of the Laboratory for Space Research. Prior to that, Quentin worked at the Royal Observatory, Edinburgh, 1986-1992, Anglo-Australian Observatory, 1992-1999, Institute for Astronomy, University of Edinburgh, 1999-2002, and then in joint position with the AAO and Macquarie University, 2002-2015, where he developed and was director of the MQ Research Center in Astronomy, Astrophysics and Astrophotonics, growing membership from 2 staff when he arrived to 50 when he left. Research activities are mainly but not exclusively associated with wide field astronomy, including being PI for the UK ST H-alpha survey, large-scale redshift surveys, galactic archaeology, supernova remnants, and especially planetary nebulae, where he has discovered more PNE than anyone in history of the field. He leads the Hong Kong AAO Strasbourg H-alpha PNE project. He has also extensive experience as an instrumentalist with multi-object fiber optic spectrographs and narrowband filters. In the last 8 years, he has taken a strong interest in the Chinese space program and the emerging new space economy. He contributes regularly on this topic on various fora Sorry, including TV, radio, and newspaper articles, where he is a regular opinion contributor to the South China Morning Post and China Daily. Academically, he has published more than 1596 papers and articles, of which 300 are referred, and has 23,500 citations with a H-index of 71. He has supervised and co-supervised about 30 PhD, MSc, MPhil, and honors students to successful completion, and is always keen to attract students. Quentin also has a long-term interest in Chinese bronze artifacts and cultural heritage, interdisciplinary studies, and science pedagogy. So, okay, this was a small presentation. And Quentin, the floor is yours. So we are curious to listen to your lecture.
Thank you very much, Adriano, for those very warm and kind words. Quite a long description of, wasn't expecting quite a voluminous description of some of the things I've done in my career, but thank you very much indeed. So everyone that's listening in live, and those I hope will listen later on YouTube, I'm going to be talking about something which I think is one of the most important challenges that humanity is facing in the 21st century, apart from, of course, the collapsing climate and the geopolitics rearing its often ugly head ever more strongly at the moment. But apart from that, there is a very serious problem about space sustainability. It's an existential threat to all our activities that we do in space, from low Earth orbit up, but I'm going to be concentrating mostly on low Earth orbit. So without further ado, I'm going to get into this presentation. So, wow, okay, you've just seen two satellites smash into each other and create an enormous debris field. So this debris field consists of small and large particles and objects moving at high speed in all kinds of different directions, creating something that you'll see later poses a severe threat to all our activities in space. And you may not realize it, but much of modern life depends critically on what's up there in low Earth orbit. And I'll explain that as we go forward. So the key pitch in my presentation is about something called the Kessler Syndrome. And as Adriano said, it's the cascading catastrophic collapse, and a bit of alliteration I've put together of the space environment's ability to actually put satellites there that can live there safely. And it's not just satellites, it's space telescopes for science, it's space stations with human occupants. And all of those are under threat from the Kessler Syndrome. I think it's one of the most pressing 21st century issues for both environmental and sustainability reasons of low Earth orbit. And at the moment, low Earth orbit is where most of the satellites reside that we're putting up there in all these mega constellations from Elon Musk, etc. And this ecosystem is creating a ground-based economy, which is predicted to be worth about 1.5 trillion US dollars by the middle of the next decade, according to the World Economic Forum and the investment bank Morgan Stanley. So we have a very strong vested interest, it seems, to protect this environment, not just because of the size of the capital loss that would accrue, but in fact, how much of our modern lives depend on data that comes down from satellites in space. And also other things that these satellites do for us, which I'll get to. So the key pitch is we must avert this catastrophe. Now, there is a body under the United Nations called the United Nations Office for Outer Space Affairs, UNOSA, and they define space sustainability as the ability to maintain the conduct of space activities indefinitely into the future in a manner that is safe, peaceful, and responsible to meet the needs of present generations while preserving the outer space environment for future activities and limiting harm to terrestrial life. Now, if you want to learn more, you can just click on the link there. Now, the summary that was given earlier was about human health in space, so I'll just leave that slide there and move on to the next one, because it's already been read out in the beginning by Adriano. So first, a little bit about actually where I'm from and what I do. I'm, as Adriano said, the director of something called the Laboratory of Space Research at the University of Hong Kong. This research lab has been going since 2017. If you actually want to check it, you can simply Google Lab for Space Research Hong Kong U, click on images, and you'll kind of get a visual summary of all our activities over the last several years. And we've actually been really active in all sorts of different ways. And you get a kind of feel for that just by doing a quick Google images search if you're interested. We have a great website, and like all good websites, we have a mission statement for our lab, and we actually have 3 mission statements because I think 3 is a good number in China, apparently. So let's have 3 of them. And the first one is to emerge as a leading interdisciplinary research center in space and planetary sciences in the Asian region with strong identity. I think we've achieved that mission. The second mission statement is to maintain and grow the LSR to be internationally recognized brand for research excellence in mainstream space science related programs, including debris. And I believe we've achieved that mission. And our third mission statement is to strengthen and develop our ties to the mainland space science program and globally. And that will be a mission which will be ongoing. I mean, we're always trying to strengthen and develop our ties. We're always trying to get more involved in the activities of the global space community. And so anyway, there are 3 mission statements on our website. Very simple, worldwideweb.lsr.hku.hk. And we also have it in traditional and simplified Chinese. So we have skin in the game. When I'm talking about, you know, oh, I want to preserve the space environment. Why? Well, because we have a vested interest in keeping it available for science, for doing space missions. Like here is a picture of our Lobster Eye X-ray telescope that was launched in July 2020. Now, it actually re-entered the Earth's atmosphere safely in August of 2023. And so this satellite was the first for Hong Kong U. And so that was our first and exciting space mission. Now, this is something we signed with the ILOA group. ILOA stands for International Lunar Observatory Association of Hawaii. This picture of Steve Durst and myself. He's the owner and director of ILOA, and Hong Kong U, I'm the director of the LSR. And we signed an MOU about a lunar mission that we've got, and that is a mission to the moon in November 2026, which is a small optical camera which we'll be putting on the moon, assuming we can get the spacecraft safely through low Earth orbit. Now, every year we produce an annual report. You can find it on the web. This is the latest one. No, that's from 2023, sorry. And the bottom left-hand corner is a piece of moon rock, which we got back from Chang'e 5. It was the first university in Hong Kong to get some moon rock back from that sample return mission that China did. And this is a little bit of a pitch for a major meeting we're running in May next year called the Asia Pacific Regional Meeting of the International Astronomical Union. And you'll see in the bottom right-hand corner of the rightmost panel that, in fact, we're going to be having one of the 9 themes is on space sustainability, the subject of this webinar. And so that's going to be an important component now that we've added in, apart from all the astrophysical topics we'll be covering that. And this meeting will host people from about 30 countries, maybe up to 1,000 astronomers, the largest such meeting ever held in Hong Kong. And we're very proud to be running it. We got Nobel laureates and Shaw Prize laureates and Gruber Cosmology Prize winner already organized as plenary speakers. Right. So let's put in now the commercial context to the whole issue. And here is just a few slides about the tremendous growth there's been in something called new space. That is a commercial exploitation of space, and in particular, the low Earth orbit environment from a few hundred kilometers up to 1,000 or so kilometers above our heads is low Earth orbit. Now, if you look at what we're currently worth, and this is now a slide is 2 or 3 years old, it's now in excess of $500 million, but the various areas where the money is going are still basically the same. Ground equipment, space, satellite industry, non-satellite and space budgets, commercial human space flight, all those kinds of things. Launch capabilities, manufacturing, the ground equipment to record the signals from the satellites, telecommunications, remote sensing. This entire ecosystem is currently worth about $500 billion US, and it's, as I said, expected to be about $1.8 trillion by the middle of the next decade. And so new space, as I said, refers to the emergence of the private space industry. Such ventures are becoming increasingly common, and they're spanning all sorts of areas. There's like private launch companies, you know, like SpaceX and Blue Origin in the United States, and various companies now are emerging in China too. The delivery of small satellite constellations to very large satellite constellations also, even suborbital tourism, where for a cool $1 million US, you can spend 10 minutes in a rocket going up to near the Kármán line and then come back down again and land where you took off. I don't personally think that's a great use of $1 million US, but some people do. And anyway, I think space tourism as a general future activity is definitely something that's on the cards. So if you look at the kind of launches that's happening, you can see on the top left here that China has a lot of activity now. Roscosmos has gone back down. Arianespace is in there. And you've got Indian activity as well now. And even the Japanese, South Koreans, and the UK even is trying to get into the space launch business, and New Zealand. But the big players today are America and China. But in America, the interesting change has been that, and you can see it in the bottom right-hand panel as well, is the number of launches from SpaceX with their Falcon series of rockets launching thousands of Starlink satellites. I remember back in 2021, I thought, oh, look, China's got 56 launches, a world record, and it's overtaken America. I wonder where that's going to go. And then all of a sudden, you can see exactly where it's gone. You've got a company, SpaceX, under the control of the billionaire Elon Musk, who's quite famous for all sorts of different reasons, now dominating the American launch market, almost getting to a monopoly. And so, one has to ask, actually, is this actually a good thing? But anyway, that's now the current situation. So we're talking about low Earth orbit, and that is the ecosystem between about 200 kilometers to about 2,000 kilometers. There's about 10,000 odd satellites occupying that ecosystem, and we're adding to it at the level about 2,400 satellites per year at the moment, but that's going to increase. If objects were to collide at the typical speeds you're talking about up there, you're looking at collision impacts of 9 to 14 kilometers per second, or about 32,000 to 50,000 kilometers per hour. And that's a huge velocity that we're talking about. Now, here again, you can see the number of satellites launched until about 2023, so it's already a year and a bit out of date, and the number of satellites launched and where they come from. OneWeb, Starlink, and commercial small sats are now making up the bulk of missions into low Earth orbit. Non-for-profit, government, civil, and government military making up very small fractions now of total launches. And that wasn't the case in terms of percentage fractions just going back 10 years. So there's a huge, huge growth, just at the same time as the cost to launch a kilogram into space has dropped down by factors of many. So the new reality we're all living in is one of rapid change, where advances in miniaturization and robotics and fuel systems and rocket technologies and reusability, et cetera, is increasing productivity, it's increasing affordability, it's providing new capabilities, and its greater resiliency and economic growth is resulting from it. And you can see in this quite complicated slide, there's a lot of things going on. Satellite manufacturing improving in all sorts of ways, launch capacity improving in all sorts of ways, reliability, the frequency of the launches, the cadence, and the options that are there for customers are increasing. And satellite services are being provided. It's all kinds of services, which I'll get into later, that satellites provide for us humans here on Earth. And with change brings opportunities, of course, but against this apparently wonderful story, there is actually, I wouldn't say there's an elephant in the room. I think there's probably a herd of elephants clambering around in the china shop, actually. And we'll get to explore that as this talk progresses. So if you look at the kind of satellites that are planned, and this is slightly out of date. I think there's up to 50,000 small satellites are now estimated are going to be produced and launched in the next few years. You've got Starlink, of course, already got thousands of satellites up there. It talks about 12,000 planned. I think that's increased significantly. The state-owned China, in fact, there are 3 China constellations now. This is just one of them. That's going to be putting up in together about 20,000 satellites, and the various other smaller players in that ecosystem as well. And so, yes, things are getting very crowded, and there's talk of 50 to 60,000 new satellites going up there in the next few years. And so if you want to make money off this ecosystem, and that's what people are doing it for, really, to realize this 1.8 trillion US dollar economy, is that it has 6 broad components that have been determined. And there's going to credit to Kevin McConnell and Kelly Kedis Ogborn for creating this slide. If you want a thriving space ecosystem, you're looking at emergent technology, you're looking at sustainability of the ecosystem, which is what this is all about, partnerships globally, macroeconomic trends that need to be investigated and followed, the critical national interests that are observed, and geopolitics. These all things are operating interchangeably in various complex ways, where sometimes one of these broad components becomes much more important than others. And at the moment, geopolitics is playing an important role in actually depressing the capabilities for global partnerships on the direct opposite side of that pie chart. Sustainability is the elephant in the room, which is under severe strain and threat, and that's what this talk is mostly about. And then you've got people like me in academia who are trying to knock on the door of everyone that will listen and say, hey, people, I think you better wake up to this sustainability issue, because if you don't, the problem won't be solvable, because it will already have solved itself by making the ecosystem completely unviable. So that's the $1.8 trillion thriving space ecosystem that we all want to see, but there is a huge, huge threat. So the Kessler Syndrome, as I said, it does sound a bit like a medical condition. Oh, I've got the Kessler Syndrome. Oh dear, please take a glass of water with this pill. But no, I mean, the Kessler Syndrome actually is this catastrophic cascading collapse of everything in low Earth orbit due to impacts from a huge swarm and clouds of space debris. Because what the Kessler Syndrome hypothesizes is that once you get beyond a certain critical mass of debris, it becomes a self-sustaining catastrophic collapse of the environment due to bits of debris crashing into a satellite, which creates another debris field, which then crashes into more satellites, another debris field, and so on and so forth. And you get this chain reaction. And that's what we're trying to avoid. So if you want to look in Wikipedia, and I know that a lot of people go to Wikipedia for nearly everything, unless they now ask ChatGPT or some other of these AI tools, which I'm trying to avoid because I'm a dinosaur. I'm quite old, even though I know I look not so old, but I am quite old. And I'm trying to do things without AI at the moment, but it's tempting because it's getting quite good. It's getting scarily good in some ways. And that's another issue which is worth another webinar all on its own. But anyway, you can read what it says. Donald J. Kessler, way back in 1978, came up with this idea about the density of objects, space pollution, space debris, getting out of control and creating a destructive envelope of where you can't do anything in it anymore because everything's just debris. So it's not just about securing new space for commercial purposes. It's actually also about planetary protection. And the reason is that a large fraction of the data that we use to try to understand the ecosystem of our own planet and how the environment is being degraded and changed almost on a daily basis, it seems, with a flow of ever more serious climate impacts in terms of desertification, ice caps melting, sea levels rising, storms getting more frequent, wildfires everywhere, glaciers disappearing, heat getting increasingly desperate in certain countries, etc., etc. But how do we actually measure all of that? How do we know what's going on with our planet? Apart from sensors we have on the ground and in oceans, we actually get a lot of our data from satellites in space looking at our planet using remote sensing technologies. And what do? They monitor the weather, of course. They look at cloud cover. They look at sea level temperatures. They look at sea level rise, looking at melting of the ice caps, deforestation, desertification, pollution, wildfires, and many other parameters which monitor health and sustainability of our planet. So if you lose low Earth orbit due to the Kessler Syndrome, we also lose a very strong armament we have to understand how we can not only monitor our planet's health, but try to see where the worst effects are, try to get help and assistance, try to understand how we can mitigate the serious climate impacts through the data we acquire from our satellites. And so it's also about much in our life that we take for granted. Space-based internet, telecommunications, IoT, supporting efficient logistics, shipping, transport, etc., energy management. All of this comes from monitoring of that satellites do in low Earth orbit and beyond. And so all of this is under direct threat from the Kessler Syndrome. So much of our daily lives, everything we take for granted, you know, everybody using one of these to do lots of things every day, those don't work properly anymore. And so people will start to get angry. In fact, some nations have been modeling public unrest due to the Kessler Syndrome happening. So I'm in Hong Kong. We think we have, as a global city, we have a whole series of strings to our bow, and not just as a global financial center, #3 in the world, not just with 5 universities in the global top 100, which is unique for any city, actually, but also the compliance, the regulatory framework, and investment ecosystem we have that could funnel money and technologies in the right areas to make an impact in space sustainability. So that's my pitch for my own city, where I've been living for the last 10 years. And so this is what we also need to secure. We need to secure the ecosystem so all this can continue. So here's a graph on the left that just shows the number of active satellites from 1957 to 2022. When I look at that, I also think it looks like the number of parts per million of carbon dioxide in our atmosphere over the last few years as well. But anyway, on the right-hand side, we look at a number of objects in Earth orbit by object type, and you can see there's lots of light jumps, which is created by fragmentation impacts. You've got launches going up, and then you've got the number of objects. Now, some things come down because objects, if they're in low Earth orbit, eventually will re-enter the Earth's atmosphere. Because even though you're in low Earth orbit, that orbit isn't in pure vacuum. There's still tiny amounts of atmosphere up there, which act as a drag, a natural drag on satellites up there. So, for example, typical CubeSats might have an operational lifetime of up to 5 years, and then they kind of just deorbit themselves, actually. But a lot of objects are much higher orbit. If you don't do anything, they're going to be up there as threats for creating debris fields for hundreds of years. So anyway, so the orbital traffic is getting crazy. So here's a plot again, time on the x-axis, a number of objects weighing more than 100 kilograms in low Earth orbit on the left-hand y-axis. And you can see everybody else has also been increasing their impact and population of low Earth orbit. But look at Starlink from Elon Musk. The thing about that is, I'm not sure it's advertised very much, but Elon Musk had to move his satellites out of the way more than 26,000 times to prevent collisions with space objects. Now, fortunately, SpaceX's satellites contain enough fuel to enable them, and techniques that enable them to do maneuvers in orbit to some degree. And but you know, the other thing we don't know, we can't track the debris bigger than 10 centimeters. So this is moving out of the way of an object that's at least 10 centimeters in size. But that's another story which I'll get to as well. Now, Kessler Syndrome. You've got a plot on the right with 2 vertical blue lines between 2030 something and 2040 something. Now, those 2 blue lines are the earliest and latest, which the models predict that if we don't do anything to try to solve the problem of space debris, the Kessler Syndrome will happen in that window. That's not long ago. It's not long from now. So you've got the total amount of objects, you've got the trackable impacts and mission-related debris, you've got explosion fragments, collision fragments, and together you've got the total amount of debris that's greater than 10 centimeters, growing quite strongly year on year. And so this is actually quite scary, this plot, when you think of when the Kessler Syndrome could happen. And what are we doing about it? How are we solving it? Not nearly as quickly as we need to. Not nearly, there's nothing cost effective that works at the moment to do this. As an astronomer, I also care about what I can see with ground-based telescopes. And when you look at this wonderful image, you can just about see the Milky Way there. And then you've got all these dotted lines everywhere. And then you've got one streak. The streak of continuous light is the only natural thing in that entire photograph, apart from the small dots, which are stars. That is a meteor. Everything else you're seeing is a satellite. A stack of 30 minutes of cumulative exposures taken just a year ago. Latitude 51 north looking south. So a very large field of view, 100 degrees by 75. But that's what we've all put up there. And that is pretty darn scary if you're an astronomer wanting to do ground-based astronomy. We're putting billions of dollars into very large telescopes on the ground in Chile and Hawaii and elsewhere. But what's the point if when you look up, that's all you see? That's another issue in terms of sustainability. And it's not just for optical astronomy. Radio astronomy has the same problem because of all the interference from all the signals all these satellites are sending out in various radio frequencies as well. Now, this is taken from the Subaru telescope in Hawaii, an 8-meter telescope, taken a little while ago. And all of a sudden, the right-hand side, you'll see flashes coming in. That is space debris re-entering and burning up in the Earth's atmosphere. So I think just to give you a kind of visual little look at, this is like a live camera looking at the sky, and there you see, and you can actually see that the color in it, because there's different elements in the components of the whatever it was that entered the Earth's atmosphere showing up there. So to try to, again, talking about skin in the game, to try to start to garner more international collaboration, we ran in December 2024 at Hong Kong U, a conference supported by the International Academy of Astronautics and the United Nations Office for Outer Space Affairs, a conference on space debris and sustainability. So we had a welcome presentation from Arti Hola-Maini. She is the director of the UN Office for Outer Space Affairs. It was co-hosted by the Laboratory of Space Research, where I am, but also École Polytechnique Fédérale de Lausanne in Switzerland, their space center, under Professor Jean-Paul Knieb. And also, as I said, the IAA was under Professor Olivier Contant. And we ran this in collaboration with the Orion Astronaut Space Academy here in Hong Kong, and the 3 countries trusted broker group of China, America, and Russia were trying to act as an honest broker to try to get international collaboration for remediation of space debris. They were all there as well at this meeting. And in fact, as you can see from the flags there, the thing about Hong Kong is it's a special administrative region of China. And so we have a huge degree of autonomy, unlike what you may have heard from certain jurisdictions saying certain things. Most of that is actually not true. I've been here for 10 years constantly. I've been through the COVID and the social unrest and everything else. And I can tell you that Hong Kong is still pretty autonomous. We have our own money. We have a hard border with China. We have our own legal system with Canadian, British, New Zealand, Australian judges on the bench wearing wigs, just like they do in the UK, and everything else. And there's no Great Firewall of China. And you can see this YouTube video here. You can do Google here. You can do all of those things. Oh, all about freedom of the press. Well, because you have a free internet, you can look at any newspaper anywhere in the world at any time, actually. So, propaganda aside, we got together, all 5 permanent members of the UN Security Council nationals were at this meeting, when a meeting in Japan just 2 weeks earlier didn't get that. So I think we can act as a super connector to try to help this whole issue of space debris. So, yes, some of you may recognize this from the film Gravity, where space debris destroys a space station and everything else. And then, you get various things happening in that quite interesting movie. But anyway, so let's get back to basics and talk about what actually is space debris. Defunct satellites. We're talking about old, broken, or abandoned satellites that no longer serve a purpose, so it's basically just junk. Rocket stages that stayed up, that didn't burn up in the Earth's atmosphere because they went into high orbit, left behind after launches. Objects that had already been fragmented through previous collisions, can be quite large. And miscellaneous items. Every time an astronaut accidentally drops a spanner, oops, that's gone. That now becomes a piece of space debris. So, in terms of space situational awareness, that is, in fact, how do we know where all of this stuff is? Well, here we go. 12,540 satellites are currently orbiting, of which about 10,000 are functioning. 18,400 satellites have been launched to date, which means that almost 6,000 have already re-entered the Earth's atmosphere. They're moving at speeds, very fast speeds, as you can see there. There are about 40,500 items up there, greater than 10 centimeters. So if you look at the 12,500 currently up there satellites and look at the 40,500 objects, you can see there's like 28,000 pieces greater than 10 centimeters, which are bits of debris and not intact satellites. And in fact, if you look at stuff that's smaller than a centimeter, we've got at least 130 million pieces in low Earth orbit. So how do we actually track these things? Well, we've got satellite tracking. Various countries have this capability. NASA does it. Russia does it. Europe does it. China does it based on ground-based observations. Cataloging systems and computational modeling is used to try to track these things, generate ephemeris of their orbits when they're large enough to track, and then we can track them. Trouble is that these jurisdictions don't always share data with each other. So the catalogs are very overlapping, but they're not shared. And that's one of the first areas of important collaboration that is required, is the sharing the information we have on debris in space. So here's quite a nice animation. And you can see what looks like circles of stuff orbiting around the Earth. And the Earth is that blue thing in the middle. But the blue thing in the middle looks a bit fuzzy with a kind of a blue ring. And that blue ring of fuzziness is actually low Earth orbit. That has so many pieces of debris in it that it makes it look like that. The other stuff you're seeing there is a much higher orbit. So there's still a hell of a lot of that. So this is everything that we're tracking. So here's just a look at a vertical scale of from sea level up to over 1,000 kilometers where all these kinds of satellites are. You can see the Tiangong space station is, a few hundred kilometers up, the International Space Station just a bit lower, etc. And various Hubble Space Telescope, maybe about 500 kilometers up, etc. And so all of these things are where we put lots of important stuff for science and for commerce and for remote sensing, telecommunications, all sorts of things. So that's just another static image of what I'm talking about, with some of the risk factors colored in, from urgency for action. Green means we don't need to do anything yet, to red, if we don't do something soon, it's game over. And so you can see that the low Earth orbit is in red. And when you look at the Earth, it's like all these black dots, all like creating what looks like a planet on its own. That's all just debris in low Earth orbit. And you have these other graveyard orbits and geostationary orbits, etc., etc., etc. So it's quite an important slide. Lots of information on it. I'll leave it there, and people, if they want to, and they got YouTube, they can like freeze the YouTube of that slide, because I've talked about it for a little bit, and they can actually read it at their leisure. But see where the red is. The super spreader debris is there in orange. That's getting quite tricky. The sun synchronous orbit as well is getting lots of danger because it's not that high. It's only 600 to 1,000 kilometers. And then you've got the low Earth orbit is a really serious issue that we need to address. As an example, here's a couple of satellites that way back in 2009, seems like an age ago now, you had an Iridium-33 satellite and a Russian Cosmos 2251 satellite colliding at orbits which were 90 degrees to each other. And we were able to track the larger pieces of debris. That's sizable pieces of debris, about 1,800 pieces from those two satellites, plus tens of thousands of smaller pieces. And you can see we tracked the orbits from the two satellites, one in green, one in red. After 7 days, it started to spread out a bit. After 30 days, a bit more. 6 months, a lot more. And after a year, all over the place, all the different orbits you could think of were now in that debris field from just those two satellites. Here's another, just a table of some of the worst explosions that we've had. A lot of Russian, a lot of American. A lot of it's from residual propellant explosion. Look at another battery explosion, disintegrated, don't know why. Accidental collision, that's the one with Iridium-3 and Cosmos 2251. Intentional collision, yes. Countries were crashing satellites into each other to see if they could disable another country's satellite if necessary. And well, they did, and a massive debris field. So here in, just a few months ago, well, a couple of years ago, actually, in 2023, a mysterious Russian satellite breaks up in orbit, generating a cloud of debris. They don't know why it did. It was probably hit by another piece of debris that wasn't trackable because it was too small. But hey, if it's too small, how come it can do so much damage? Very good question. We'll get on to that. So if you look at... Oh, okay, the recording has stopped. Okay, I better hurry up.
Not a problem. Not a problem.
Not a problem. I'll keep going. I'll keep going. So the
It's
cost
just
of predictions is getting really expensive.
it is just an AI tool that is recording, but I never asked for that because it will remain on YouTube, however. So never mind. Just go
Okay,
ahead.
I'm not an AI tool, I promise you. I'm not a generated CGI. I'm a human being. Right, next. So
Yeah.
here's an interesting thing. Here's a picture of the robot arm on the International Space Station, the Canadian robot arm, with a hole in it. Okay. Now that's an impact of debris that occurred sometime before May 2021. They only saw it on May 2021, so we don't know exactly when it happened. And there's been about 30 close encounters of orbital debris requiring the evasive action of the ISS over its lifetime. And when they saw that, was a small particle punched a hole right through the robot arm. Now, of course, had that happened and it went through the main body of the space station, that could have created a major leak. It could have hit somebody and maybe killed them, but it would create a major leak anyway. But here's something to consider. I've got a nice picture of a grenade there, because think of a few grams of debris moving at 7 kilometers per second. If that hits another object, that has the explosive and destructive force of a hand grenade. Why? Because energy is a half mv squared, folks. Simple kinetic energy equation. One of the first things you learn as a physics student is E equals half mv squared. M is mass, v is velocity. Mass is small, few grams. V squared is enormous. So E equals half mv squared is still enormous. So that is why we have a problem with even a small pieces of debris. And here's another example. So here's what looks like somebody been firing bullets at a bulletproof glass. So that's kind of a bit like what happened. You've got 7mm diameter circular chips gouged out of the strongest glass and systems we have on the space station, and a couple of, in the window of the space shuttle before it was discontinued. And of course, this is maybe small flecks of paint moving at incredibly high speed, doing this damage. And several space shuttle windows have had to be replaced during the operational lifetime of the American space shuttle because of such things. Now, anything bigger than 10 centimeters, if it had hit the space shuttle, it would have destroyed it. So this is serious. And it's something from just June of last year. ISS astronauts take shelter in Boeing Starliner. Haha. It's not working anymore. I don't know if it'll fly anytime soon. But anyway, at least you've still got the Dragon capsule from SpaceX. Beautiful. So anyway, and that happened recently. And in fact, the Chinese space station, their recent missions have put extra cladding outside the Chinese space station to protect it from debris. So what are the impacts of space debris if we don't do anything? Satellite damage, astronaut hazards, economic consequences. These are all serious issues. And I said we already had that slide, so I don't need to emphasize it again. And also, what are we doing about it? So as I said, at the moment, it's a bit like the Wild West. There's no real, there might be some regulation intended, but who's enforcing it? Who's enforcing what we put up there and how often we put it up there? Who's telling the likes of Elon Musk, no, you can't put another 10,000 satellites up there? Urgent international regulation is desperately needed. It can no longer be allowed to be the Wild West, because if you keep going the way we are, it'll destroy it for everybody and every country and everything. So there's papers there, blah, blah, blah. It's all blah, blah, blah. It's all talk, talk, talk. What practical solutions are we trying to do to solve it? Are we doing anything about it? Well, all kinds of different technologies have been tested, over the last few years. None of them are cost effective at the moment. Magnetic capture, astroscale is an important player in this game. I like the laser broom, and I think actually what you need is spacecraft in orbit that can be refueled, that have the capability of acting as remediation satellites to get rid of debris for long periods of time. So each one that goes up there can remediate a large amount of debris. You can do that if you're looking at laser ablation. You fire lasers at a defunct spacecraft. It creates an ablation of the surface like a jet coming off. And if you do it carefully and sensibly, that can create a propulsion system that can direct that satellite to re-enter the Earth's atmosphere and burn up. So that's one idea I quite like. And so there are many groups investigating this problem. It's very intractable because if you think about it, these things are moving at 8 kilometers per second, sometimes in different directions. They might be tumbling. They're big. So how are you going to get up there, match the tumbling, because you'd have to stop it tumbling if you're going to capture it, all sorts of things. It's incredibly difficult, incredibly challenging, and extremely expensive. So here is, again, some ideas there. You have a piece of debris. You have a net coming out to try to capture it. It's that debris which is tumbling and rotating, and then it cups in, and then that thing can then be brought down somehow. This thing on the right here, you've got an incredibly expensive satellite, probably cost $100 million to put up there to bring back a defunct part of a rocket. I mean, is that cost effective? I don't think so, but that is what they're planning. All sorts of crazy ideas to try to solve the problem. You know, so in 2026, Clear Space, which is a spin out from École Polytechnique Fédérale de Lausanne under John Paul Knieb, supported by ESA, is going to try to retrieve a 100-kilogram piece of debris using that claw system. Okay. There are international efforts to address it, United Nations guidelines, interagency coordination, national regulations, private sector initiative. All these things are being talked about. Talk is cheap. Doing something about it, super expensive. That's why nobody wants to do it. And whose fault is it anyway? Advanced technologies, perhaps, regulatory frameworks, enforceable, but mandated action. If you don't do it, you get into trouble. International cooperation desperately needed. Public-private partnership will not occur until there's money to be made, which will come eventually if we get things right. So, here in Hong Kong, I was part of a group of 4 that put together a whole list of things from a workshop we ran that had 35 stakeholders from insurance and business and aerospace and and legal and everything, and academics and aerospace companies all coming together to try to nut out something our city might be able to do, Hong Kong, in terms of the policy. And so all of these areas were covered: commercial, securities, business, insurance, compliance, legal, regulatory, science, tech, engineering, education, talent, strategic and policy dimensions, including the global significance, the geopolitics, and above all, the risk of doing nothing. So we think that it's not a wild dream for our city to play a global role because we have so many strong cards to play. Other players in this field like Luxembourg, the Grand Duchy of Luxembourg, and Singapore, similar sized jurisdictions to ours in many ways, do not have our advantages of global fintech superpower, tertiary education, punch way above our weight with 5 universities in global top 100, close to the GBA with 60 million people with an economy almost the size of that of the UK. And so a lot going on. So China, can China do anything? China is not responsible for most of the debris. That is the fault of Russia and America over 60 years. But China has contributed something. However, it could show the world not only is it a responsible spacefaring power, I think that's already fairly self-evident if you look at what they've done, but one that can put key global space issues ahead of purely national interests for the good of all humankind. By developing practical, cost-effective, commercially attractive debris remediation technologies that could solve the problem. China's 1.2 odd billion people. It's invested hugely in high-tech infrastructure and education. It has the talent, the capacity, and the scalable industries to actually address this problem for the world. It would be like leadership in climate change and renewables. It could do the same for these important goals. So that's what I'm hoping might happen. And once China starts, other countries will come on, I'm sure. So what about Hong Kong? Beautiful city of Hong Kong, skyline at the bottom. We had that important space sustainability conference with 70+ international senior conference participants, including representative of the US government indirectly, is that we think our city could play a very valuable role in space sustainability and being a new space hub, a global one, because we can leverage our internationally respected expertise in compliance, regulation, rule of law, reputation and prowess as an investment powerhouse, global financial center, investment talent magnet, which together with our elite university technology incubators provide everything that you actually need, and right next to a big manufacturing center that could work. We want to collaborate both within Hong Kong and our universities across into the GBA and mainland China, but also especially internationally. It's only through international collaboration that when we put aside our own selfish vested interests, that if we don't do it, we will not save this ecosystem and it will be game over. So, Hong Kong again, let's do this. Let's see what we can do. And the time to invest to protect the future of low Earth orbit is not tomorrow, not yesterday, it's today. Let's do it. We need to do it. Thank you very much for your attention. That's it, folks. Thank you.
Thank you. Thank you very much. Thank you very much, Quentin. It was a beautiful, beautiful lecture. And yeah, we have people watching.
Well, I'm happy to answer any questions. Well, try to anyway. Those people are interested. Shall I stop sharing the screen?
Yes, sure. You can stop.
Right.
Now we only have appreciations so far.
Oh, well, that's nice.
Yeah.
I'm glad I haven't wasted my time.
No.
It's
really
nearly 10
interesting.
p.m. here for me in Hong Kong. 10 p.m. for me, but I thought this is so important. I want to try to get this message across to as many people as I can. It's only through sharing messages like this that action can actually start. When people start getting concerned, start writing to their politicians and start agitating and start, maybe they know somebody who's important that can say something or whatever. It takes this kind of thing multiple times by multiple people saying the same thing for people to listen.
Yes, you're fully. I would like to ask you about one point. There is if you consider the Outer Space Treaty, there is one issue is that each object that is in space is still property of the state that launched it, or better, is under the responsibility of that state. This, I think, is a big obstacle in the future management of space debris, because I think that if, for instance, China wants to remove a piece of debris that belongs to Russia or to US, it becomes an issue.
Yes, exactly right. Which is why nothing's happening. And in fact, if it's a piece of debris that's only 10 centimeters inside, how do you decide which satellite it came from? Now, obviously, the big bits, yes, we can say, oh, look, it's got the Russian flag on it. I think it's Russian, or it's got NASA on it. I think it's American, or it's got France on it, and European flags. Oh, it must be from European Space Agency, etc. But when you have a piece of debris that's 10 centimeters inside, and that's the stuff that's actually the most dangerous in some senses. Of course, low-hanging fruit, let's get rid of the big debris, because that stops them becoming vast numbers of small debris. But a lot of those are in higher orbits, which aren't so problematic, but some are. And this is what the 3 countries trusted broker group of Russia, China, and America are trying to do, is that they need to agree to exactly what you're saying, Alberto. And do you see that happening anytime soon?
Well,
needs to, or else we're screwed. Sorry.
No, but yeah, we have something else to add to this. Let me say, general problem that if we only see it like a moral question, that is important because it is a moral question. I think the problem will never be solved. We also have to think about that as a business opportunity. For instance, most of the big debris that are in orbit are stages of some rockets that are made of aluminum, and that's a precious material in orbit, because from aluminum we could get fuel. From aluminum we could use that aluminum to generate fuel for rockets in orbit. That would be very important, because generating fuel in orbit will decrease the cost of any launch in the future for any mission.
There's about 30,000 tons of debris up there, including aluminium and other kinds of precious metals,
Exactly.
gold, and everything else. But the trouble is, it's not sitting there in a single body like an asteroid. It's spread out over vast distances at different speeds in different orbits in different directions. And so it's a really, really difficult problem, actually. And so that's one thing. And, you know, mining space debris has been suggested quite a few times. But, you know, and I think, you know, you're right about the commercial side. Without it, I don't think we're going to solve it. You know, look at it this way. We look at our roads in our cities and in our countries, and you know, we have people driving cars and buses and everything, and lorries all over these roads. And how do they use these roads? They pay a tax. They pay, you know, tolls. They pay taxes to use those roads, so you can resurface them. You can add another lane. You can put safety features in, whatever. What do we have up in space to use the space environment? Nothing. We don't know anything. So if every single launch you started putting a tax in where that money was collected and was used as an investment to solve the problem, that's one aspect I think that we could look at. One thing.
Yeah.
But you're right, Adriana. Yeah.
By the way, you know, we have already in Space NASA, we have already developed some papers on that, and we presented IAC in the past years, because we think that orbital debris is one of the main problems and opportunities, and should be tackled with very much higher priority than what it is.
100%.
And there were also some proposals, mainly advanced by the NSS, the National Space Society, and by the way, by Alfred Anzaldúa and some colleagues, to create some kind of structure to make how it was called, the bounty, some kind of bounty proposal.
Yep. There's all sorts of ideas, Adriano. You really are.
Yeah.
There are many others, and as I said, they're all talking.
Yeah, of course. No, but look,
nothing is actually happening.
What we as a non-governative organization, we can only talk. We can only make proposals. We develop. We study the problem from a philosophical and political point of view, and we make proposals. Then, of course, it will be to the companies and to the governments to say, "Oh, that's interesting. Let's do it." It's not.
You see, the trouble is also the timescales between all these wonderful ideas and these proposals, and you know, and things is fine, but people aren't taking responsibility. Nation states aren't taking responsibility. There's not the necessary levels of agreement and collaboration and mandated action that's enforceable. And who's going to enforce it? Who's going to pay for it before it even gets to the chance of being commercially viable? China, for example, has now for several years a policy that every single satellite and thing it puts up into space will be able to be brought down itself through its own technology. But that's not really the issue anymore. Even if every nation, spacefaring nation has that kind of thing, it's not that. It's that we're putting up thousands of extra satellites every year. So we're adding more stuff to it at a faster rate that anything can be brought down. So the problem is just getting exacerbated. That's the problem.
I believe that the new satellites, since a few years to now, have on board the orbiting device.
Yeah, I just said so. Yeah, most do.
Yeah.
That's not the problem.
So, okay, this is a step forward. But however, to make these precious materials to burn in the atmosphere, it will be a waste.
We could
better reuse them, because it costed a lot to put it in orbit. When it is in orbit,
absolutely. Look,
it holds a delta V. It holds a delta V. That's also an important property. So it would be better to reuse them better than firing.
How? Tell me how.
Okay. Yeah. First of all, we have to catch them. And for medium and big debris, it will not be a big problem. I think there are already working prototypes, let me say.
You've seen them, I've shown you them.
But the problem is to catch the small debris, because that is really an important, big problem, I think. And they are problem too, because a small debris can make a hole in your spacecraft and depressurize it. Yeah, it is like a bullet traveling at 27,000
You
kilometers
did see
per
my
hour.
talk, Adriano, didn't you? I did show you
Yeah.
that.
Yeah.
So,
Okay.
look, yes, these are good points, and I agree with you 100% on all of them. And these are well known, and also people are discussing them and writing articles about them and putting proposals in about them and trying to do something about it. But the fact of the matter is, there is no coordinated, significant program
Yeah.
that's to do it. We've now got a few, as I said, ESA has paid Clear Space to have a go in 2026 to bring down 100 kilograms. There's 50,000 tons of debris up there, which is debris, not active satellites. If you could put it all together in a ball, we could mine it. We could get the useful stuff out of it. It's the same idea as asteroid mining, which hasn't taken off, even though many companies have come and gone and lost all their money, because at the moment it's just completely unfeasible. That's the problem. And so we need to tackle it somehow, and we need to pay for it somehow. We need to get international collaboration somehow. We can't stick a head in the ground, and pretend and hope it'll go away. It won't go away. So we're like this intelligent species, which is this wonderful environment that we keep putting stuff into it, on a super highway that's getting more and more crowded, and all of a sudden it's going to be a huge car crash. And it's going to really be serious. And so anyway, thank you, Adriano. These are very, very good points. I appreciate
Sorry. We have a couple of questions now.
Okay.
Can I?
Sure.
So this is Mahesh Harilela.
Yes.
He said, do we think that the development of laser could be a solution, while some think it could be a military tool, while some think it could be a military tool?
Yes. Well, you can say that pretty much about anything you put up in space. A robot arm of the Chinese space station, unlike the robot arm of the International Space Station, of course, could be used to grab hold of satellites. Now, the International Space Station is up in a certain orbit going at a certain speed. What's it going to do? Wait until something happens to come past, which would be a collision, and try to grab it or match it? It's just nonsense. So that kind of lasers, yes, they're used for telecommunications in satellites, between satellites. That's a big new use of them in constellations for keeping their arrays in the right order, etc. And you could use them to attack a satellite if you were so inclined, but we can also use them to remediate debris. Yes, Mahesh, that's a very good question. And anything, anything could be turned into a weapon. John Wick kills people with a pen. In his movies. So,
well, I think all human-made tools can be used for good and for bad. From the very beginning of the human history, when first man understood that taking a branch of a tree, he can use it to kill some animals for eating, or even to kill some friend, another human.
Yeah.
So and the same is today. You can use we had a blatant case in 2001 with the Twin Towers, where when a big airplane was used to crash in a skyscraper. And so if you have knives in your kitchen, it can be used to cook food for the good, or can be used to kill a person. So that is true for every tool that we have. It can be used for good and for bad. And that depends that is a moral problem, an ethical problem, not a technological problem. Of course, we cannot make a technology that is not possible to be used for bad. I think, yeah.
Was there
Okay,
another question? I thought you said there was another question.
I think no. At the moment, I don't see anything.
Thanks, Mahesh.
So I think, okay. So Alberto, if you don't have other things.
I have one thing. It's about this. Maybe since Elon Musk is putting so many satellites in orbit, I think he is one of the causes of crowding crowding space and increasing the problem. But on the other point of view, he's one who could be strongly affected if things go wrong. So, is he doing something? Will he be motivated to do something? I just wonder about this because if nations don't do it, maybe a private entity can do it. A private
Well,
entity that is so much
he's
interesting.
rich. He's extremely rich, and perhaps before going to Mars, he could clean up the backyard so that
Maybe.
Mars missions can actually go up there safely without crashing into debris as they launch. So you'd think he'd have a very strong vested interest in trying to be part of the solution and not contributing to the problem.
Yes,
Very good point.
definitely. You're right. Okay, so I think we have to thank you very much
No,
for your
thank you, everybody.
for
Thank
your
you,
patience.
thank you, Alberto. Thank you, Mahesh,
Thank
for
you,
your
Quentin.
question.
And we will have more. We have more of these meetings, and so if you want to come back to us, you are very welcome. And
Thank you very much for the
okay,
invitation. It's been a pleasure working with you two gentlemen. Thank you very much, and good luck for your wonderful series. And I hope some people pay attention to this YouTube video.
yeah, no, they will be sure, be sure. I'm sorry that Ganim was not able to join again because his computer is suffering a bad problem.
Good condition, okay.
Yeah, okay.
And
However,
gremlins again.
Okay.
Thanks, everybody. Take care.
thank you very
Thank you
much.
very much.
Take care. Bye bye.
Bye.
Bye.